equivalent circuit of a 200 by 400 volts transformer is shown below with capacitive load. Okay, capacitive load is on the secondary side. Okay, now calculate the power factor of the circuit drawn from the supply. Power factor is defined as in many ways. Okay, it is the angle between voltage and current at the supply side, since we have to find the power factor of the supply, or you can find cos phi, that is cos phi, as R by Z, resistance by impedance from the supply side. Okay, or we can also have one more formula as real power by total apparent power. Okay, these are the three formulas for power factor. So cos phi s I will prefer here as R by Z, okay, which is seen from the source. If you see here in the secondary side, the 10 ohms inductive reactance is equal to 10 ohms capacitive reactance. What does it mean? That the secondary side of the circuit is in resonance. Okay, at resonance the total impedance is equal to resistance. Okay, so 8 ohms only is available on the secondary side. When you refer this circuit from secondary to primary side, okay, now we have the parameters like this: 2 plus 4j, okay, plus 8 by 4. What is this 4? It is given as k square, where k is equal to transformation ratio, that is n2 by n1. Here it is 2 by 1, which is equal to 2. So on the secondary side only we have 8 ohms. When it is referred to primary, it will become 8 by 4. Okay, now this is equal to 4 plus 4j. Now what is phi from this? Phi is equal to tan inverse x by r, okay, which is equal to tan inverse of 1, 45 degrees. From this, cos phi is equal to cos 45, 1 by root 2, which is 0.707. Okay, if you see here, we have inductive reactance, since we have plus sign in the imaginary part. Okay, this is 0.707 lagging power factor. So option B is correct answer.
For the open circuit shown below, find the V0 for t greater than 0. Here Va equals to 0, Ia is nothing but C dV by dt. Here V is nothing but V of 0 e power minus t by R1 into C, which is nothing but 3 e power minus 10t. Okay, now I is nothing but 20 into 10 power 3. Sorry, this is I is nothing but 5 into 10 power minus 6 farads into dV by dt. It means into minus 30 e power minus 10t. Okay, now this is I. V0 is nothing but IRF, which is nothing but here minus 150 into 10 power minus 6 e power minus 10t into 80 into 10 power 3. So if we do the calculation for this, that is 150 into exponential minus 6 into 80 into exponential 3, we will get it as 12, that is this is going to be plus 12 e power minus 10t, because here the minus sign is I is also negative. We wanted to calculate V0. So minus I into RF, it is going to be a plus. Hence option B is correct. So the following relationships holds good. A is the non-minimum phase filter. Here the definition for the non-minimum phase is nothing but, here in non-minimum phase all the zeros or some of the zeros can be in the right hand side of the S plane, but all the poles must be in the towards the left half of the S plane. Whereas in minimum phase filter, all the poles as well as all the zeros must be in the left half of the S plane. Comes to all pass filter, in case of all pass filter, poles and zeros are exactly a mirror replication. Means for a stable system, the poles must be in the left half of the S plane. Means the zeros must be in the right half of the S plane for all pass filter. So that we can arrange like this. After knowing to the definition of the A, B, C, we came to know that option A is the correct answer. Question is a real valued signal x of n whose power is 5 and its real power is 1 by 2 whole power mod n, and the power in output is, we know that total power is nothing but power in output plus power in even part. Here 1 by x naught of n whole square, n is minus infinite to infinite, n is minus infinite to infinite, xe of n whole square. So even power is nothing but minus 1 plus 2e power n equals to 0 to infinity 1 by 2 power n, which is 5 by 3. So p naught is nothing but 5 minus 5 by 3, which is 10 by 3. Hence option B is correct. Question is, a certain DAC has the lowest and highest of resistances 1K and 8K respectively. If the bit length of the converter is increased by 2, what would be the additional resistor and their values? Now, here 2 power n minus 1 into R is 8 kilohertz and 2 power 0 R is 2 kilohertz. Means 2 power n minus 1 is equals to 4, that is 2 square. N minus 1 is 2, n is equal to 3. If the bit length is increased by 2, then n dash is nothing but n plus 2, that is 5. The number of additional resistors will be 2. Then the values would be 16K and 32K, hence option B is correct. Question is, match the list 1 with list 2. List 1, the type of feedback is given, whereas in list 2, effect on R input and R output is given. In case of voltage series, what happens is, we are taking the voltage from the output node, means that is a parallel connection which will decrease the output resistance. Means R out decreases, whereas series connection increases the input. Comes to B, R out decreases, shunt connection is also, both are decreases. Comes to C, current series, R out as well as R in both increases. Comes to D, current shunt means output increases but input decreases. Hence comes to voltage series means output decreases, input increases. So A is 1. Voltage shunt means both decreases, hence it is 3. Current series means both increases, hence option 2. Comes to D, current shunt means the remaining option 4. So A, B, C, D. 1, 3, 2, 4.